Welcome to all. I am Dr. A.Mary Odilya TEENA, Assistant Professor, PG Department of Computer Applications, St. Joseph College, Cuddalore. In this video lesson, I am going to explain about the basic concepts of combinational circuits in digital electronics. What is combinational circuit? The combinational circuits are very well-known component in digital electronics. It provides the output instantly based on the current input. Unlike sequential circuit, the combinational circuit listens for input signal and generates output no matter what is the past input or state. Since the output depends on the present combination of the input, so no memory component or feedback is needed. It only cares about present input and state. The combinational circuits are made up of input variables, logic gates, and output variables. So this is a block diagram of combinational circuit. Here n number of inputs and it produces m number of outputs. There are some commonly features of combinational circuit. The output depends only upon present input. Its speed is fast. It is easily designed. It is the elementary building blocks of logic gate. It is used for both arithmetic and Boolean operations. There are types of combinational circuits: adder, subtractor, decoder, encoder, multiplexer, demultiplexer. Now we'll see one by one. Adder is a combinational circuit which is used to perform mathematical operations of binary numbers. It is a combinational circuit. It performs the addition of binary digits or bits. The adder is categorized into half adder and full adder. Half adder is simply we can say adding 2 bits. Full adder means adding 3 bits. Now we'll see what is half adder. Half adder is a combinational circuit which adds 2 single bit numbers. In this block diagram, the inputs are denoted by A and B and the output is denoted by sum and carry. The two inputs are A and B is 0, 0, 0, 1, 1, 0, 1, 1. If you add 0 plus 0, the output sum is 0 and the carry is 0. If you add 0 plus 1, you will get the sum 1 and there is no carry, so 0. If you add 1 plus 0, the sum is 1 and the carry is 0. If you add 1 plus 1, the sum is 0 and the carry is 1. Now look at the logic diagram. The Boolean expression for the sum is A exclusive or B. The expression of the A exclusive or B is A bar B plus A B bar. It is simply denoted by A exclusive or B. The carry of the half adder is A and B. Next we'll see the full adder. Full adder is a combinational circuit which simply adds 3 input and produces 2 output. The inputs are denoted by A, B and C and the outputs are denoted by sum and carry. Now look at the input. Look at the truth table. The input values are 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Adding 0 plus 0 plus 0, the sum is 0 and the carry is 0. Adding 0 plus 0 plus 1, the sum is 1 and the carry is 0. In this way, the all values are formed. Next, we'll see the off subtractor. The off subtractor is subtracting the 2 bits. The 2 inputs are A and B and the 2 outputs are denoted by D and B. That is difference and borrow. It produces the difference between the 2 binary bits at the input and also produces an output borrow to indicate if a 1 has been borrowed. Now look at the truth table. If you subtract A minus B, that is 0 minus 0, the difference is 0 and the borrow is 0. If you subtract 0 minus 1, the difference is 1 and the borrow is 1. If you subtract 1 minus 0, the difference is 1 and the borrow is 0. If you subtract 1 minus 1, the difference is 0 and the borrow is 0. So in this way, the truth table is designed. In binary subtraction, A minus B, A is called minute bit and B is called a subtrahend bit. So this is a logic diagram of the subtractor, and the expression of the subtractor difference is A exclusive or B is shown in the figure. Next we'll see the full subtractor. The full subtractor is subtracting the 3 bits. The 3 inputs are A, B and B in, that is borrow in, and the 2 outputs are B and B out, that is borrow out. Here A is the minute bit and B is the subtrahend bit and B in is the previous borrow bit produced by the previous stage. So the difference output and B out is the borrow output. Now look at the truth table. The values are, there are 8 values. The values are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Subtracting 0 minus 0 minus 0, the difference is 0 and the borrow is 0. Subtracting 0 minus 0 minus 1, you will get the difference is 1 and the borrow is 1. Subtracting 0 minus 1, 1 and the minus 0, the difference you will get 1 and the borrow is 1. In this way, the truth table is formed. Next, we'll see the decoder. The decoder is a combination circuit that converts a binary code into a normal word like a decimal digit. In simply, we can say the decoder consists of n input lines and m output lines. It is widely used in display drivers, data distribution systems, etc. Some commonly used types of decoders are 2 to 4 decoder, 3 to 8 decoder, 4 to 16 decoder, and BCD to 7 segment decoder. For example, 2 to 4 decoder, the input lines are 2 and the output lines are 4. In 3 to 8 decoder, it consists of 3 input lines, 8 output lines. In 4 to 16 decoder consists of 4 input lines and 16 output lines. Next, encoder. An encoder is also a combination circuit that performs the reverse operation of the decoder. The word is very, very important. It performs the reverse operation of the decoder. So it has a maximum of 2 power n input lines and n output lines. For example, in 4 to 2 decoder, it consists of 4 input lines and 2 output lines. 2 power 2 is equal to 4. So 4 input lines and 2 output lines. The octal to binary encoder is also called 8 to 3 encoder. It consists of 8 input lines and 3 output lines because 2 power 3 is equal to 8. So 8 input lines and 3 output lines. Then 16 hexadecimal to binary encoder. 16 to 4 encoder is also called hexadecimal to binary encoder. So it consists of 16 input lines and 4 binary output lines. Next we'll see multiplexer. Multiplexer is simply denoted as MUX. It is a special type of combination logic circuit. It consists of n data input lines, 1 output and m select lines. That is n equal to 2 power m. So depending on the number of the input lines, there are several types of multiplexers can be formed. They are 2 cross 1 multiplexer, 4 cross 1 multiplexer, 8 cross 1 multiplexer, 16 cross 1 multiplexer, etc. For example, in 2 cross 1 multiplexer, the input line is 2 and the output line is 1. Simply we can say multiplexer consists of many input lines but only one output line. For example, in 8 cross 1 multiplexer, the input lines are 8 but the output line is 1. So there are m select lines. In 8 cross 1 multiplexer, 3 selection line is used. the selection line is used for the multiplexer, which is used to select the input line. So the selection of the desired data input to flow through the output line is controlled with the help of the selection lines. Next, we'll see the demultiplexer. It is denoted as DEMUX. It performs a distribution operations. That is, it receives one data input and distributes it over several output lines. It is also known as data distributor because it receives single input and produces several outputs. So in this block diagram consists of one input line and M output lines and M select lines. At a time, only one output line is selected by the digital code applied to the select lines and the data input is transmitted to the selected output lines. Some commonly used demultiplexers are 1x2 demultiplexer, 1x4 demultiplexer, 1 to 16 demultiplexer, and 1 to 32 demultiplexer. For example, 1 to 4 demultiplexer, the input is 1 and the output lines are 4, and we need 2 selection lines is used for select the output. So in this way, the combinatorial circuit is designed. Thank you for watching.